Imagine holding a simple glass bottle in your hand, clear, smooth, perfectly shaped, and realizing that this everyday object has survived fire hotter than molten lava, been stretched and blown like sugar taffy, sculpted with sub-millimeter precision, and filled with liquid at speeds that would blur before the human eye. And today on The How Factory, we're pulling back the curtain to reveal the astonishing, fiery, thunderous world of mass production glass bottle manufacturing, showing step by step how millions of bottles are melted, molded, inspected, and filled every single day in one of the most demanding, high-speed industrial environments on Earth. And it all begins long before the first drop of molten glass even touches a mold, starting instead with the raw ingredients: silica sand, soda ash, limestone, and small percentages of recycled cullet glass. Materials that seem ordinary on their own but combine to form the backbone of a product that must be strong enough to withstand transport, pressure, carbonation, bottling lines, and even tampering. And factories know that the recipe must be balanced exactly. Too much silica, and the melt becomes overly viscous and energy hungry. Too much soda ash, and the mixture melts easily but becomes fragile. Too much limestone, and the final glass may resist water but warp under heat. So the batch room, the factory's brain, is where computers precisely weigh each ingredient to fractions of a gram, blending them into a homogeneous granular mix that flows like dry snow before being sent by conveyor into the furnace. A massive cathedral of fire constructed from refractory brick and engineered to run continuously for years at temperatures exceeding 1,500 degrees Celsius. Where inside the inferno, the batch transforms from powders to glowing molten orange liquid glass, resembling thick honey made of light. And as the mixture melts, heavy impurities sink, bubbles rise, and mechanical stirrers ensure the molten mass becomes crystal clear and perfectly uniform, because even microscopic variations could weaken the finished bottle. After molten refinement, the blazing river of glass flows toward the Forehearth, a long temperature-controlled channel where the molten stream cools slightly from furnace temperatures but must remain at the perfect forming heat, usually between 1,100 and 1,300 degrees Celsius, creating a thick, well-conditioned, molten ribbon that will soon be sliced into precisely measured portions known as gobs, molten droplets of glowing glass the size of small apples that are cut by mechanical shears synchronized to the millisecond. And here, the choreography becomes breathtaking. Each gob drops into a chute and is fed into an individual section machine called an IS machine, one of the most iconic and complex pieces of factory equipment ever built. Essentially a row of highly synchronized forming stations that work like a team of glass-shaping robots, each station receiving its own gob of molten glass and immediately capturing it in a blank mold where compressed air blows the interior to form the initial cavity shape, while the exterior is formed by the mold's steel walls. And within seconds, this preformed parison is transferred to a final mold where more air expands it into the bottle's full shape, cooling just enough to retain structural integrity, yet staying hot enough to allow adjustments, producing a finished bottle that exits the mold, glowing red and soft, yet perfectly shaped. But in this environment, speed is everything. Modern IS machines can produce up to 700 bottles per minute across multiple sections, requiring mechanical precision so reliable that a single misaligned mold, temperature fluctuation, or slow shear cut could ruin thousands of bottles. And to prevent that, sensors constantly measure gob weight, mold temperature, air pressure, and timing, correcting errors in real time to maintain consistent quality. Once shaped, the newborn bottles are carried by conveyor through a Lehr, an annealing oven designed not to heat the bottles but to cool them gradually, because rapid cooling would introduce internal stress that might not show visibly but could cause explosive breakage later. And so the Lehr slowly steps the temperature down over 30 minutes to an hour, ensuring the structural stability of each bottle. And as they exit, the bottles no longer glow red. They now appear clear, green, amber, or blue, depending on additives such as iron, chromium, sulfur, cobalt, or carbon used to tint the glass. And from here, the bottles undergo some of the toughest quality inspections in manufacturing, because the stakes are high. Bottles must withstand internal carbonation pressure, transport vibration, capping torque, and thermal shock from hot fills, so sophisticated inspection. Stations use high-speed cameras, polarized lighting, lasers, airflow tests, and mechanical gauges to check every dimension, detect cracks invisible to the human eye, find chips on the rim, identify thin walls, verify base thickness, and ensure the opening is perfectly cylindrical, so caps or corks will seal without leaks. Any bottle failing even a single criterion is instantly ejected by a pneumatic arm and sent back as cullet to be remelted, because in glass factories, nothing is wasted if it can be remelted. And now, the acceptable bottles travel toward labeling, or directly to the filling line depending on the product type. Where factories move from the world of fire to the world of speed, sanitation, and automation, starting with bottle rinsers that blast the interior with sterile air or high-pressure water jets to remove microscopic dust, followed by filling machines that operate like industrial symphonies, rotating carousels fitted with dozens of filling valves that simultaneously fill multiple bottles with incredible accuracy, whether it's water, soda, beer, juice, or oil, often without any spillage thanks to vacuum-assisted or pressure-assisted filling technologies. And as the bottles spin through the carousel, sensors ensure correct volume, temperature, and flow rate, adjusting in real time. Then comes capping or sealing, another high-precision step where metal caps, plastic closures, corks, or twist-offs are applied using torque-controlled heads that must seal tightly enough to hold pressure, but not so tightly that customers can't open them. And after sealing, bottles move to labeling stations where glue-based or pressure-sensitive labels are applied with remarkable alignment accuracy, rotating the bottle so labels land at the exact orientation, free of bubbles or wrinkles, and then coating or laser etching machines print batch numbers, expiration dates, and production times for traceability, ensuring every bottle can be traced back to its exact manufacturing moment. Next, bottles are packed into cartons, crates, or shrink-wrapped trays using robotic arms equipped with vacuum grippers or mechanical clamps that can pick up dozens of bottles at once without squeezing too hard, placing them with precision into packaging that must survive long-distance shipping and harsh storage conditions. And once packaged, products move to automated palletizers that stack cases into tall, stable pallets, wrapping them with tension-controlled plastic film to create a secure load, which forklifts transport to massive distribution warehouses, ready to be shipped to stores, restaurants, and homes around the world. But what's even more remarkable is how every part of the factory is designed to operate almost continuously, 24 hours a day, 7 days a week, because shutting down a glass furnace is not as simple as flipping a switch. Cooling too quickly would crack the refractory brick structure, requiring millions of dollars in repairs, so furnaces typically run for more than a decade before needing major rebuilding, meaning teams of engineers, technicians, chemists, electricians, and machine operators constantly monitor conditions, ensuring stable heat, stable gob weight, clean cullet supply, accurate molds, and perfect timing in the IS machines. Beyond engineering, however, lies the environmental side of glass bottle production. Factories today incorporate large percentages of recycled glass, not only to reduce waste, but because cullet melts at lower temperatures than raw minerals, saving massive amounts of energy and lowering CO2 emissions, and some plants even source renewable energy or waste heat recovery systems to further reduce environmental impact, making modern glass production more efficient, cleaner, and more sustainable than ever before. And when you look at a finished bottle, flawless, strong, smooth, it's easy to forget the intensity, heat, machinery, and science behind its creation. But inside the factory, every second counts. Every degree matters, and every bottle is the result of centuries of innovation combined with modern automation, making it possible for millions of bottles to be produced and filled every single day, destined to hold the beverages, condiments, oils, and products used around the world. And as we wrap up this fiery journey from sand to shelf, remember that the next time you twist open a bottle, you're holding an object that survived temperatures hotter than volcanoes, passed through machines moving faster than the blink of an eye, and embodies the precision of one of the most sophisticated manufacturing processes ever invented. This has been The How Factory, and if you enjoyed diving deep into the fascinating world of how things work and how our modern factories keep the world running, make sure to Subscribe and stay tuned for more behind-the-scenes industrial stories. Thanks for watching from The How Factory, where we show you how the world is made.